Good afternoon, everyone. The House of Sultan and Sons Private Limited and methodAI extend a very warm welcome to all the participants of today's Artificial Intelligence webinar. It feels nice to have you all here, and we thank you for that. A bit about the House first. We are pioneers in the field of book publishing in post-independence India, catering to students from pre-primary to university level, churning out over 600 regular titles besides adding new ones to our stable year after year. Known for competently written, elegantly produced, and reasonably priced books, our publications are widely prescribed in reputed schools and colleges across the nation, as well as in some neighboring countries. Our authors are distinguished academicians, professors, and educationists with vast experience. We are proud to be associated with them. I now introduce you to the host of today's webinar, Dr. Sachin Gupta, author of Artificial Intelligence and Data Science books for classes 9th and 10th. Besides, Dr. Gupta is Dean, Research and Innovation, Maharaja Agrasen Institute of Technology, GGSIPU, Delhi. Dr. Gupta has also been HOD Computer Science Engineering and MCA Department in Dronacharya Group of Institutions, Deputy Director and Head of the Computer Science Department in Chandraprabhu Jain College of Higher Studies, affiliated to GGSIPU, Delhi. With a teaching experience of over 20 years, which includes teaching undergraduate and postgraduate students and researchers, Dr. Gupta's academic pursuits have been fairly meritorious, winning him several awards, distinctions, scholarships, including the Certificate of Academic Excellence by GGSIPU. Dr. Gupta has also contributed to various journals, conferences, and books for schools and higher education, both nationally and internationally. His achievements are truly commendable. May I now request the man himself to take you through today's session, Dr. Sachin Gupta. Have a great day ahead. Thank you.
Thank you so much for the introduction, sir. All right, I will just get into brief of why we are having this session today on rule-based versus learning-based model. We have a big group of educators with us who are all working on artificial intelligence, and there was a long drawn discussion last week on that, which wandered around that whether or not how do we classify whether some system is rule based, how do we classify whether it is learning based, it is how do we tell the student that how to differentiate between a rule based or a learning based model. And it is something very typical to understand unless and until we set some very basics of AI, because AI originated, or rather, AI is evolving so fast that initial years, when we spoke about artificial intelligence, it was only purely rule based. We would have some if then else structure. We may want to automate something on the basis of that decision framework, and we would be able to come across a final decision streaming through a large set of if then else type of statements. Soon, in 1997, the Deep Blue, the chess system by IBM, that defeated Gary Kasparov. But the question here is whether that should be considered an artificial intelligence system, or whether that should be considered a learning-based system. On whether it was rule-based or learning-based, that was still contentious. How do we decide? Because the only good part about that system was that it could compute very fast. The system had a lot of computation power, and it would be able to go through a large set of if then else statements super fast to predict what should be the next move, or to actually create the next move. There was no learning, that we did not train the system on a large number of moves. We actually trained it on a large set of if then else, and it was easy because chess has that every piece would have a limited number of moves. So whatever be the total number of rules that we may be creating, that would be limited. But with big data today, that's the system is not same anymore. So let me get into some details about what are the differences between rule-based and learning-based models first. And then we will take on a practical example for both. And in case you have any queries during the session, please put them on the chat window so that we can take care of the queries right there and there. So the topic we are going to discuss is rule-based and learning-based models. Simply speaking, in the basic definition, rule-based AI uses rules to solve a problem. The rules would be written by human experts. Please mind it, this is something very important, that the rules in rule-based systems would be created by human experts. But these rules are not learned from data, irrespective of whatever amount of data that we have, whatever amount of information that we have. That is not going to affect the rules. We as humans are going to typically write the rules here. The rule-based approaches require more expertise than machine learning, but I would have to understand that what kind of rules would this system require. And only if I have the domain understanding, I would be able to create a rule set. We will see that in an example, that what do I mean by domain expertise. And there is another issue, that the rules can be challenging to maintain, because real life, the data changes. There may be some more set of information that we might get. So my previous rule-based model might not have captured everything that we required. For example, let us say a dog has 4 legs. The weight is 10 kg. If the color is black, I may say create a set of rules like the dog is black, 4 legs, 10 kgs. And now I give the system a cow. The cow is 200 kgs, 4 legs, black. It might still distinguish it as a dog, because 2 out of the 3 rules worked. So I do not know what rule did I miss out on. I also do not know that if some rule changes, if there is a new breed coming which is not black, which is white, for example, in that case, how do I update my rule set? That every time some new rule comes, my data set changes, and then I'd have to create a new rule. So any artificial intelligence which is based on specific rules, they produce predetermined outcomes. These systems are simple AI models, as I discussed originally, that on the basis of if-then coding statement. They consist of 2 parts. On one hand, there is a set of rules that if this rule apply, then this set of facts should emerge. If the other rule apply, then the other set of facts should emerge. That is the basic fundamental component. We may have to construct the artificial intelligence system using these elements. And this was the pattern which was being followed 40, 50 years back, that people were actually drawing rules by hand, defining them. For any medical system which was AI based 40, 50 years back, so the same case for a psychiatric evaluation system like ELISA, the chatbot, it was again the same. So majority of the systems in the early era of AI, they were based on the simple if then else system. Now, rule-based AI is used for decision making. The basic classic distinction between the two is whenever we are using rule-based, it would be used for decision making. But wherever we are using machine learning, the learning-based model, this is used for prediction and classification. So this is one basic idea on how do you classify between a rule-based and a learning-based model. If your program is used for decision making, you might be working with a rule-based AI. Wherever you are, whenever you want to work with prediction and classification, it might be a simple case of machine learning. And machine learning is often used when you have a large amount of data that can be analyzed to make predictions or classifications for that matter. Rule-based AI may not have a large set of data. They may be simply having a large set of rule set with a small set of data. That works for them. The comparison for both is the rule-based AI works best with small data sets, which are less complex, that we will see in the example that we are going to take on practically in our. The rule-based AI requires the knowledge engineer to define what rules. I, as a human being, or any domain expert as a human being, they would be requiring to define the rules prior, before they need to be applied to the data to be processed by the program. Unless and until we define the rules, the system would not work. And if there is any change in one of those rules, then you need to go back, update your code accordingly, and you would be rewriting, recompiling the code, running again, waiting for when a new rule book comes. It's something like your income tax calculation, basic. Like if you have an income between so and so bracket, you'll be paying 20% tax. Between so and so bracket, you'll be paying 40% tax, and so forth. But the government brings in a new uh, rule set for income tax calculation, and in that case, you would have to write the rule book again. You create the complete program again. Otherwise, it will not work. On the other hand, the machine learning training software learns from existing data. It is based on self-learning. We don't require to tell it any rules or patterns, not upfront, not definitely. I don't need any expertise. I would not need to define that this is the rule. I don't need to be even knowing what is the domain that I'm working on, and I must still be able to use machine learning for working with that. So this is the kind of thing that we are going to observe today. In case we are going to take up two approaches to the same data set that we are going to work with. And let me bring you to my data set for the day. I'll show you what we are working with. I have a image data set from Amos. Search for Amos data set and you will be able to find out this. Okay, I mean, there are two data from Amos. So this is the data set for outdoor images. This calls for archive of many outdoor scenes, Amos. So the other one was for multi-organ systems. I have downloaded this data set. This is available for download. There are a lot of publications available, and you can find this out from here. This contains hundreds of millions of images gathered from publicly available outdoor webcams. So these webcams work like for the day images, for the night images also. There are a lot of images in this. And this is a typically large 55 terabytes of messy data set. So we have just downloaded a couple of images, something close to 200 images each of day and night. And we have posted them in this folder on my Google Drive. So as you can see, for the training, I'll be using some images from the daytime. This is for the daytime images. For the training again, I'll be using some images from the nighttime. The nighttime images are there. For similar locations, there are multiple couple of images for this. And then we might use the testing data set to test any of the images that we have available here in the day or the night time. And we'll be able to classify it whether this image is of a daytime picture or is it from a nighttime picture. So first thing first, let us try to work with the rule-based system. That how would I classify the images on the basis of the rules? From the participants, if I have to create a rule, let us not go into how would I do it. Can you please share on the chat window that what criteria, you saw the images, there is an image like this. What should be the criteria if I have to define a rule that this should be the rule by which I should be able to classify this is a night image? Think of anything that you are having in mind and let us put in the chat box that this is the kind of rule or this is the set of features according to which we are going to decide that this is a day or this is a night image. if anybody would be forthcoming. There are no wrong answers here. There can be only right or more correct answer. Alka, Mr. Murugan, Samya, anybody for that matter. You can open your mic, you can say, or you can chat it in the chat window that if I have to classify them, then what should be the basic criteria on which I would be able to define that this is the rule by which I would say this image is of a night or this image is of a day. Mind you, that humans have a different way. We see, we understand, we learn. We are learning through the childhood till this age that uh, these are the characteristics of the night, these are the characteristics of the day. So we immediately would be able to see a scene and classify that this is a night image or this is a day image. But how would I tell a computer how to classify this? Any thoughts? Please feel free with your queries. Let me build up the set in the meanwhile. So what I have done is I have taken 200 images, equal 100 day images and 100 night images. I have already mentioned the AMOS dataset, archive of many outdoor scenes. In this, I have just simply connected my Google Drive because I showed you the data here that the complete data set I have posted on my Google Drive. So this contains all the images that we require. And I have connected my Google Drive here. Imported certain libraries like OS, glob for loading images, matplotlib image, then matplotlib pyplot. This is for plotting. Then computer vision 2, random, numpy for calculation, and so forth. This was so far. Okay. I have the directory for training data coming from the images on training. I have the directory for testing data coming from the images of the testing that we had classified earlier. Now, I just have loaded the data set here for all the images. Read the image and append it to the list. So I just created a list. So load all the images and their labels and place them into a list. Okay. And then I am just looking at one image. So for image index 30, for instance, I am just plotting the image on here. And at the same time, I'm printing the shape of the image. The shape of the image would tell you what is the total number of pixels horizontally, vertically, and what is the total number of channels. So it's a RGB image. There are 3 channels in this. All colored images typically do have 3 channels. But so we are printing one image here. Similarly, I'm taking one image from the night data set. The image index is 192. And I have shown it here with what is the resolution of the images and the number of channels. I see something coming on the chat window. Let me open up this quick. Okay. Okay. Snehal from YouTube says classification is one. Okay. I would classify based on certain criteria. Snail is perfectly correct that we are going to classify the images. But all right, I'll go into a very small brief again, diverting from the topic. We usually typically associate any machine learning or any AI based system to learn from data. When I say data, data always has features. This image has certain features like this has the 3 channels. This has 555 pixels on the vertical, sorry, and 800 pixels on the horizontal side. Each pixel of an image is a feature. So for text, the characters are features. For images, the pixels are features, and likewise. So your features may be like for the human, my age, my face, skin color, my hair color, my eye color, all of them can be features. my height, my weight. So there are a lot of things that we can say that these are the attributes of the data by which we can classify. So I can classify dogs and cats like that dogs have uh, four legs, then there is the tail, then there is the canine tooth, and the cats may be more furry as compared to dogs. They may be having a longer tail. Their eye color is something different. So these are the features on which we are going to classify. So this is the same thing here. If I want to, true, my operations is classification. I want to classify the images as day or night. But at the same time, I want to be able to understand that on what feature do I classify. So that is basically the requirement of a machine learning model. So far, we are working on the rule-based data set only. So there is nothing like we are not going to apply any ML here. We are going to think of the way that AI developers of 50 years back, how would they have done it? That is the operation right now. So as I see, my images are of different sizes. The resolution of this image is different, 471, 640. The resolution of this image is different, 555, 800. I want to first standardize that let all of the images have same resolution of pixels, both the sides. So in the pre-processing, what I have just done is I use a computer vision library to resize the images for a 1100 cross 600 pixel. That means every image that I have, irrespective of what its original size was, I'm just converting it to 1100 cross 600 pixels. And then I encode the labels that, because machines understand numbers better. So when I say my image has a label called day, I'm labeling it as 1. And whenever my image has a label of night, I'm labeling it as a 0. So that is my simple rule here. After that, I'm pre-processing it, the complete image list, and standardize and encode the input data. So I am taking every image, converting that into a standardized. I use the function standardize input. This would convert all the images into a 1100 cross 600 pixels. And then I'm also encoding the label. If it is a day image, I would encode it as 1. If it is a night image, I encode it as 0. So this gives me my standardized list. And now check out the image again, that for image number 30, I have the shape of the image as 600 cross 1100. The number of channels remain the same because we did not process that, right? And that would be applied to all the images in my data set, that every image, irrespective of whatever its size was, they are now 600 cross 1100. Okay. In the meanwhile, you can keep thinking. If you want to come across that this is the feature by which we are going to decide that this is a day image or a night image, I would still love to have your thoughts while we are pre-processing as of now. So how do you extract the features? Now, each image is, I told you there are 3 channels, but I can represent an image as a HSV model also. HSV is hue saturation and V channel, which is a measure of brightness, right? So the feature which we are going to classify the images is based on brightness. How bright is the image? If it is bright, it is daytime. If it is not bright, then it is probably nighttime. There are some images which fall in between the categories, like the dusk or the dawn, where images may be moderately bright, moderately dark, but we do not know what time of the day it is. But for a daytime image, it is bright. For a nighttime image, this is not so bright. Now, I have the RGB model. I need to convert that to HSV first. That is the first requirement. So I'll take up, and each pixel has a certain brightness. So the average, what I would require to do is, for creating my rule-based model, I would take each pixel, I would extract the brightness of this pixel. I would add all the pixels brightness of the complete image. That means I would be having 600 into 1100 total pixels in a particular image. I would take the brightness of all of them, sum them up, and divide by the total number of pixels. So this is what I am doing in the next step. For each image, first thing, I am converting that to a hue saturation volume. where HSV would be using a CV2 function, CVT color. Then I take a sum of brightness of all the images. HSV has again three channels: hue, saturation, and the V channel. So V channel is the only one which we are taking. Remaining we are leaving. So I'm using a NumPy array to sum all of these values into one specific value called sum of brightness. This is for each image. And then the area of the image is 600 cross 1100. This is the total number of pixels. And I find the average, the total brightness of all the pixels divided by the area. This returns me the average. So value range is between 0 to 255. That means from the darker to from a 0 would be white, from a 255 would be black. That can be any range of value between these. Okay. So now I would test the average brightness level. Let us take an image number 178 from the standardized list and run this function, the average brightness function, where we feed an image, and for the image it is going to give us that what is the average brightness of all the pixels summed up together divided by the area. So for this image, the average brightness is 99.62, to a long degree of calculation that comes. And you see the images for the human, this is a night image. Correct? Apply this rule to every image that we are trying to find out what is the brightness, average brightness of the image. So far, we have just calculated the brightness, but we have not decided a rule yet. So for all those who are listening in, you now have the very easy idea about that we classify the images on the basis of whether it is more bright, daytime, whether it is less bright, nighttime. We have already calculated the brightness of each of the image. Now we just have to find one value against which we would be able to test. So my if then else rule structure would be, if the image brightness is greater than this number, it would be day. If the image brightness is less than this number, it would be night. So my rule-based AI is set, all set. This is all we are going to do later now. So we build a classifier as extract the average brightness feature from an image, use the predicted label. It would be 0 or 1. That means use the feature to predict whether it is day or night, 0 or 1. And initially the predicted label is 0. I define a threshold here. Threshold is the value above which we would say that this is a day image, and below which is say this is going to be night. So if average brightness of the image is greater than the threshold value, this is classified as a day. Predicted label is 1. Otherwise, the predicted label would be staying 0. That means it can be predicted to be night. Right. After that, what we are doing is nothing more. Take the test image list, pick an image from there, pre-process it, shuffle it randomly, and test it, that whether the label of the image that we are feeding it from the testing, what does it predict? So let us say we give it an image A. For the image A, it says this is a day, looking at the brightness. So my model would be able to now classify by feeding it an image. It is going to tell whether it is a day image or a night image, like that. So now we also want to get the misclassified image. Let us suppose I fed it a day image and it was giving me the label as night. That is a misclassified. This comes up later whenever we want to actually check how accurately my model is working. But the idea behind it is the same, that I'm just simply looking at my original label was day. It is classifying it as night. There is a mistake. My original label was night. It is classifying it as day. There is a mistake again. So that is the kind of scenario that we are working on. So all the misclassified images are also counted, and all the properly classified images are counted. Later on, we'll think of some evaluation measure to calculate it. So far, if there are any queries, please post them to the chat box, or I can go across. So what I'm summarizing, whatever we have done so far. We took the images. We have them on my Google Drive. I took every image and standardized it. Standardized it in the way that whatever was the resolution of the image, I converted it to a 600 cross 1100 pixels using computer vision library. Then using computer vision again, I have converted all the images from RGB model to HSV because V tells us about the brightness of the image. After that, I took in the brightness of each pixel across the image, summed them up, all the pixels brightness, and divided it by the area of the image, that is resolution 600 cross 1100 multiply करके I divided the brightness of the image. That gives me what is the average brightness of each particular pixel. After that, I decided a threshold. This threshold would be the one. This is my rule that if the average brightness of the image is greater than threshold, it is daytime. If the average brightness of the image is less than threshold, it would be nighttime. So far that we have done. And after that, we are also trying to evaluate the model as how many images it is correctly identifying as day and how many images it is incorrectly identifying. That part is misclassified images. All right. So now we have also calculated the accuracy with the number of misclassified images out of the total that we are going to later understand. Here, the threshold that we are taking is 99. There comes some accuracy. Okay. This is my actual function for calculation that going back to, so my if then else structure is built in this complete function. So from these steps, this is the only classifier we have built in the complete set of rules. We have not created any other rule. We have just created one single rule, that what is the average brightness of the image, or what is the average brightness of all the pixels taken together in this image. If it is greater than my threshold, it is day. If it is less than my threshold, it is night. Right. My system has an accuracy of roughly 93% on my data set. It has a 90% precision, and there is a 96% recall with a F1 score of 93.3. This we are going to take up in another session later on, that what is the significance of all these. So true negative is that the image was supposed to be dark and my classifier classified it as dark. False positive is that image was supposed to be either dark or light, but it classified it in a different category, and likewise. Okay. So we received an accuracy of 93.75 by using only one feature, a single feature extraction, that is the average brightness of the image. We may have more features extracted, but how many features? How to decide the threshold value? How do you decide that 100 was the right value? Why would I not take the threshold as 80 or 60 or 70 that way? Right. Let me change the threshold value here, so that the threshold value when I'm calling define function, here. Okay. I can change the value of threshold here, and it would give me a different result every time I am going to change it. This was the first way of doing it. If we test it on any image, it is going to be able to tell us, or it is going to classify my complete data set into day or night images by feeding it an image. Now, coming to how are we going to do it with a learning based model. I hope there are no queries on the rule based model. You understand what was the one single rule that we applied here with image processing. Should we go ahead to take the learning based model for the same? We'll keep the same data set. We are going to work on the similar set of images, but we are going to create a different view. So for that, we are going to use a teachable machine. I hope all of you are familiar with this. I'm going to post the link for this in your chat window, so that all those who want to use it, they can reproduce the same. Right. So you have the link on here. But we are going to now work on the teachable machine to see how it works. Let us get started. I do not know any coding as of now. Let me forget that I know Python or I know computer vision or I know any kind of coding. I have nothing, absolutely nothing. I'm starting from the scratch. I'll create a new project which is image based because I want to classify the images as day and night. So taking an image, and there are two kinds of model here: a standard image model which works with laptops and machines which have a lot of computation, versus the embedded image model which works for a smaller size images, works for microcontroller or for small memory devices. So we have a regular device, we'll use this. Correct. There is, it just simply says there are two classes. There is a training and there is a preview. So for the first, let us define our classes as day and another class as night. Okay. We would require to train it. We will have to give it some data on which how to learn. That I'm not giving it any rule. I'm just giving it that these are the examples. Please learn from it by yourself. You don't have to actually ask me what rule on which I have to classify. So let us upload some images for the day. Now the images are available in my Google Drive, or I can choose them from my file. So let us import them from the Google Drive. I had pasted them on the training data. Within the training, I have the set of day images. Let us select all of them. There would be 50 here. Select. Let us see while the images get added here. So the samples are loaded. It has loaded some 53 image samples, which are all of them are daytime, as you can see. You can observe that they are daytime. The computer does not know yet. Similarly, we are going to upload some images from the night. Let us take them from my Google Drive. Same data set from the training. I have the night images. Let us select the images from here. There are more. Select some of them. I'm not taking a balance. That means there are some images which I am taking for the day. Jitni load ho gayi thi, that I added for the day. For the night, jitni load ho gayi, I have added for the night. I can remove all the images from here and try uploading again by letting it load for a longer time. Maybe I'll have to wait for a bit. So for the day images, let us now select again. We have selected all, but there are more. Okay. So selecting all of them and adding. So far, so good. I have my training data set ready, but I have not trained my model yet. So my image samples for the day classifier. This is supervised learning, of course, that we are telling the model that this is a day image, the other is a night image. Correct. Called train model here. We have to keep on the focus on this window. We don't need to change the focus because while the system trains, it requires you to be having focus on this. So it says don't switch tabs. You must leave this tab open to train your model. Okay. So it's taking the images from the training, from the day, from the night, taking all the images, processing it. We don't have to give it a rule yet. We could add a class for dawn, dusk. If I wanted to classify into day, night, dawn, and dusk, that would have been more. The model is trained now. Correct. And now you can either export the model. This goes to that whatever it has learned, it creates a mathematical model kind of thing. I'm not using it in any project. I want to run it here and now. I can pick a file from my system and then let us choose it from my files. So from the home, I have the same images data set here. This was the training, this was testing. Let us test the image which is coming from the night. Select All right. And then what happens is I just needed to now check that how does it classify. So with 100% prediction, it says, or with 100% confidence, the model says it's a night image. Let us classify the image, some other image, taking from the test data. So from the test data, I'll take a random one, anyone, and let us see how it says, what it says about it. So it says there is 100% confidence that the image is a day image. Now I'll come back to my rule set. I told you that with the slideshow that rule-based works with small data sets which are less complex. I could have a very complex image instead of day and night classifier. I wanted to classify it as the types of terrain, whether it is a Greenland, whether it is an Iceland, whether it is a water body, whether it is a desert, or whether it is some kind of that. I would also need to require what rules to be applied. In this case, I needed to understand what was the threshold against which the image would be classified as day or night. If I do not know the threshold, I would not be able to work. And if the rule changes, that means if I am having a rule like I might be seated in a lighted room without being able to classify it's a day or night. So only for outdoor images, the rule works. For indoor images, I might have to actually think of a different rule. But machine learning software learns from existing data. It does not require you to have anything else added to here. So, and at the same time, I did not need to do any programming here. I did not have to define any rule. I just had to give this to my machine. It learns from examples, creates the rules by itself, understand what is the differences of the characteristics in here. It does not even ask me on what criteria do you want to classify. And it is going to do the task by itself with a far more accuracy than I could have thought. My accuracy with my model, which was 93% or 94%, it is giving me almost 100% accuracy for the same. So that is the kind of work that we are looking into when we say image-based, a rule-based versus a learning-based model. The question that we were discussing in the groups that actually pertain to decision trees, now on the chat window, how many would say, just I'm asking decision tree, tell me whether it is a rule-based model or a learning-based model. Keep in mind this also, and think about it, that who all say this is a rule-based model versus a learning-based model. The chat window is open so that you can see the inputs from all of you. What is the decision-based tree? Decision tree? Would it be a rule-based model or a learning-based model? Okay, I get one. Alkas Anand say rule-based. Okay. Ramya says rule-based. Good. What about others? I want to see how it polls because this is important. This is something that we have had a long discussion on. Okay, YouTube also says rule-based. Please understand that how are you creating the decision tree? If the decision tree is being created, I'll define it again. If the decision tree is being created based on the rules which human experts have written, it is a rule-based model. If, on the other hand, your decision tree is being created by a machine learning model, it is going to be learning based. If it is learning from the data, it is a learning based model. So this is a very common misconception that decision trees are rule based, because the examples that we give in our books for teaching the student that the decision tree is a if then else structure. You select that if this is if the threshold is 90, this is a day. If the threshold is above 90, this is, or below 90, this is night. Or if the temperature is less than 18 degrees, it is cold. If the temperature is greater than 18 degrees, it is warm, or something, some rules like that. When we are creating the rule set by ourselves, then the rule sets are simple. The data may be less. The number of features on which we are making the rules are only 2 or 3 or 4. So you want to buy a house, and for that, the size of the house, the number of rooms, the garage is there or not, how furnished it is. These are some of the parameters on which we are going to make a decision. But if the number of parameters are limited, you can create a rule-based model. You can create a rule-based decision tree where you would be able to classify. But what if the number of parameters on which you have to choose is, say, 50 or 100? How are you going to be able to create a rule set which applies to 100 different levels of, and for all of them, there are different permutations and combinations? That would not work. In that case, it is very easy to give it to take all the data for all the houses which are available in and around in Delhi. Maybe there we have a collection of 100 lakh or 1 lakh houses in Delhi with their prices, with all the features that we are looking. Let us say there are 50 features on which we are classifying. So for 50 features, for 1 lakh houses, if we give it to a machine learning model, which is going to learn from data instead of we supplying the rules, after the model learns, if we give it a set of features, it would be able to correctly predict that the cost of this house should be somewhere around this. We are not actually now making a decision here. We are actually trying to classify or predict a value that this would be the house price roughly on the basis of these parameters. Right. The same applies for majority of the rule-based system, which if they have a bulk of data, if they have a lot of parameters, then, and if we apply a machine learning model which learns from data, this would become a learning based model. But so far as in a small set of rules is concerned, or a small set of decision making is concerned, or the number of parameters are very less, this remains a rule based model. So the answer to this question would be dependent on what is the total number of rules, what is the total number of parameters, and are we as humans are going to create the rule set, or is the machine learning the rule by itself? So with the image classifier, we chose what was the rule to decide whether the image was a day or a night. So we decided that this is the rule. For a learning based model, in this, we did not give it a rule. We did not choose a rule. We did not tell anything to it, but it could still classify. So this could be converted into a decision tree. Just turn this image upside down. So on one hand, the only decision that you are making is a single parameter, whether the threshold or whether the average brightness is less than 100 or more than 100. So it would be day or night. That's the only simple decision tree that we are going to make. But there may be several other parameters also. So when a machine learns from data itself, it's always a learning based model. But when the humans are setting the rules for something, that becomes a rule based model. I hope that actually allows us to clarify. If there are any queries, please feel free to ask. We still have roughly 10 minutes remaining to close the session, and I'll keep my chat window open to see any query that you may have, and I'll open them as required. I'll wait for queries for a minute before we close. Anything, any question that comes to your mind, we'll be very glad to answer the same. Alka, does it satisfy? Do you find the answer okay? Ramya and YouTube. I hope the information given is clear enough. Thank you so much. Any other questions, please? Or we can conclude the session. All right, sir. I hope we can close.
Thank you once again, Dr. Sachin Gupta, for this engrossing session. On behalf of the House of Sultan and Sons Private Limited and methodAI, I thank all the participants of today's webinar.
Okay,
As you
there's a
all know,
question. Sorry to interrupt you, sir. How
no,
is
it's okay.
classification different from clustering? Okay. So clustering is going into the domain when we do not have a supervised, when we do not have any labels, when we do not know on what parameters to classify. So when I had to classify between cats and dogs, I know that one category is cats. I have some labels. My data is labeled. I am classifying it into either category, apples, oranges, or grapes, or any other thing for that matter. But classifying is something like I have a set of people who have different food habits or have different learning habits, or some students are fast and slow learners in your jargon. So based on the characteristics only, if I can classify people into different groups without telling that what is the classification, then all of those who would have similar interest, they would be clustered into one cluster without even knowing what does this cluster represent. So clustering is when we have unlabeled data, when the learning is unsupervised, when we do not know anything about the data prior, but we can simply trying to find out more about that, which groups are similar in some respect. Then we later try to find out what is the similarity about. That was clustering. Classification, we know in advance that what are the categories on which we are classifying. I hope that answers it. Sorry for interrupting you, sir.
No, it's okay. Go ahead, please.
There are no questions coming up.
Okay. As everyone knows that this was the third of a series of AI webinars, you will be duly notified when the next session comes up. Thank you once again for being there. Stay safe. Thank you.